Hello. In today's lesson, we're going to review the solving of equations. This will be a nice lead-in to the more difficult topic, which is formula manipulation. So let's begin with our first example. It says x minus 4 is equal to 1. When we're isolating x, we make sure we use the opposite operation. So instead of subtraction of 4, we will have addition of 4 on the other side of the equation. So x is 1 plus 4, or 5. Question 2. Once again, in isolating x, we perform the opposite operation. Instead of division by 4, we will be multiplying on the right side by 4. So x is negative 2 multiplied by 4, or negative 8. Problem 3 involves two separate operations. First, we isolate 5x. So that means changing from subtraction of 2 to addition of 2 on the right side. We now have 5x is 15. In isolating x, we realize that the implied operation here is multiplication, so that x is found by using division by 5. The opposite of multiplication by 5 is division by 5. And so here, x is 15 divided by 5, or 3. In question 4, on the left side, we have 8 minus 5t. This is the same as a negative 5t plus 8 on that left side. And question 4 can now be solved just like problem 3. So first, we isolate negative 5t. We change addition of 8 to subtraction of 8 on the right side. So negative 5t is equal to 10. And t will be found if we divide both sides by negative 5. Again, the implied operation here is multiplication. And so what we are doing is the opposite, which is division by negative 5. And so t here is negative 2. Okay, so it's important not to talk about signs changing, but rather operations changing from subtraction to addition, from division to multiplication, and so on. Okay, number 5 can be rewritten this way. 4l plus 6 on the left side. The right side is a negative 3l plus 5. Now this question is different because our variable, of course, is in two different terms. So this problem involves collection of like terms. So I'm going to have the terms containing L on the left side, and those without L will be on the right side. So in moving this term to the left side, we have to change from subtraction to addition, like this. So 4L plus 3L. On the right side of the equal sign, we already have the number 5. And we'll be bringing this term to the right side. So once again, it will change from addition of 6 to subtraction of 6. So that's called the collection of like terms. How many L's do we have now? 7 L's. 5 minus 6 is -1. To find L, or to isolate L, we have to divide by 7. Again, the opposite of this implied multiplication is this division. And we would leave this answer just like this, because if you tried to actually take -1 and divide it by 7 with your calculator, you would get a not very nice looking decimal answer, and we don't want to round our answers at all. We want exact answers, and that makes the fraction here preferable. Okay, let's take a look at the top here at problem 6. We've got a bracket now, okay? So what we need to do to begin the problem is to actually open up the bracket like this. So realize that when we do that, we're taking -2 and multiplying it by the terms inside the bracket. And that will look like this. We will have -2x followed by +10. Okay, so -2 is multiplied by x, and -2 is multiplied by -5. So that makes the left side now, if we collect these two like terms, we'll have 3x plus 10 is 4x minus 2. And now we have the two terms containing x and two terms without x. So we must collect like terms. So the terms with x I will bring to the left side. So the 3x is already on the left side. 4x has to move to the left side. It's currently a positive quantity, so we must subtract 4x. The number -2 is already on the right side of the equal sign. The 10 is moving to the right side, so it changes from addition of 10 to subtraction of 10. 3x minus 4x will give you -1x. -2 minus 10 is -12. So finally, to isolate x, we need to divide both sides of the equation by -1. So x is -12 divided by -1. X is 12. Number 7, very much the same type of question. We have to start here, opening up that bracket, which means multiplying both terms inside by 1/2. So let's start there. We do 0.5 times 4. This is equal to 2. And then 0.5 times -t will give us -0.5t. Okay, so that's our first step, much like in number 6, where we started by expanding the bracket, opening up the bracket. Okay, on the right side now, what do I have? I have -0.5t, and I have 2 minus 0.8, which is +1.2, like that. Okay, now when we look at these terms, we find that 2 of them contain t and 1 of them does not. So we proceed by collecting like terms. So the terms with t I would like on the left side, so that means this term goes to the left side. It will be added, so this is currently a negative or subtracted quantity. So on the left side, it is added. (1.9t) plus 1/2 a t is 2.4t. So how is t found? By dividing 1.2 by 2.4. Okay, and if you carry out the division here, you will get the answer 0.5. Okay, this is the same as 12 over 24, which is also 1/2. Okay, so if you prefer a fraction as your answer, you could leave it 1 over 2, but as a decimal, it would be 0.5. Okay, problem 8. We call this a proportion. When you have two ratios and they are set equal to each other, this is called a proportion. And there are many ways that you can solve this. Lots of students here would use cross multiplication, and that would be great. Another option, of course, is isolating x simply by changing division by 42 into multiplication by 42. So x would be 3/7 times 42. Okay, but maybe I'll show you the cross multiplication because I think that most students prefer that method. So if you're going to cross multiply, multiply in the direction of x first. So this way. So you'd get 7 times x equals, and then you multiply this way. So you get 3 times 42. And then in finding x, all you have to do is divide both sides by 7. So x is 3 times 42 divided by 7. Okay, which is what we said we would get here originally if all we did was change from division by 42 to multiplication by 42. We would have 3/7 times 42, which is the same as what we have here using our cross multiplication. And then you can just put this into your calculator. 3 times 42 divided by 7 is going to give you 18. Okay, we'll do 2 more problems together. So here we have number 9. Number 9 has 2x on the left side, and we've got this fraction on the right side. Okay, one way to start the problem, and I'd probably recommend this, we have division by 4. It would be very nice to eliminate the fraction by changing division by 4 into multiplication by 4. So the left side of the equation is 2x times 4, or 8x. Okay, so I like that start very much because we've eliminated the fraction on the right side already. So 2x times 4 is 8x. And now you can see what we're going to do. We're going to expand the bracket here, which means multiplying both terms inside of the bracket by -5 to give us a -35 and a positive 15x. Collection of like terms requires this term containing x to go to the left side. Addition becomes subtraction. Eight minus 15 is -7, so we have -7x on the left side, and on the right side, 3 subtract 35 is equal to -32. So what value does x have? It is -32 divided by -7. We will leave this as a fraction because if you put this division into your calculator, again, you'll get a bit of a mess. But in a fractional answer, you would never leave both numerator and denominator negative. This is the same as an overall answer of positive 32/7. Okay, so if both numerator and denominator are negative, it's the same as an overall positive fraction. Okay, one last problem we're going to do together. You can see that number 10 has these vertical lines about x, and you might know that these are absolute value signs. So we're going to solve for x given 2 times the absolute value of x minus 1 is 3. So we proceed by isolating the absolute value of x. So this requires two operations. First, we have to change from subtraction of 1 to addition of 1. So the right side is 3 plus 1, or 4. So we now have this. 2 times the absolute value of x is 4. Continue to isolate the absolute value of x. So this requires us to divide by 2. Change from the implied multiplication to division. And we now have this. The absolute value of x is 2. So what we want to know is what values can x assume? We need to know what this statement means. It means the distance from 0 to x on the number line is equal to 2. So I'm drawing a number line here. 0 would be here. X is found by moving 2 units. Now it's distance, so we can move 2 units to the right to get right here. Or we can move 2 units to the left to get right here. So x has 2 values. They are positive 2 and negative 2, which we often just write like this. X is equal to positive or negative 2. Okay, so again, this means the distance from 0 to x on the number line is equal to 2. So x is here and x is here, 2 units away from 0. Okay, so the takeaway from the lesson today is that in every step we are performing the opposite operation as we isolate our variable. And this very important concept will drive our next lessons on formula manipulation. So thanks for watching. I will certainly have suggested problems from your textbook posted for you in Blackboard. Okay, have a great day.